Right. So all of you, are you able to see my Excel sheet?
Yes, sir.
Yes, sir.
See here the same problem.
Yeah.
Same problem. I have vendor A 120 data, vendor B 120 data, vendor C 120 data. I want you to total it. I'm sure all of you know how to total using Excel, right?
Yes.
What is the formula? Look at the formula. You equal to summation of select all the data. Isn't it?
Yeah.
That will give 685. Same way you can get this 731. Same way you can get this. This average, not required. Anyway, it was calculated. Now, actually, why I calculated average is just to show you. And whose average time is low? B's average is low.
Yeah.
Right? B is 5.7 only, isn't it? So
Yeah.
B, sorry, not B, is vendor A.
Yeah.
It is in B column. Vendor A is faster compared to B and C. So either you look at the average or you look at the total, the conclusion is same. When you look at the total, I could see a difference of 45.9 in the number. The lowest number is 685, highest number is 731, and there is a difference of 45.9. And my only doubt is whether this difference is significant or not. When I use my normal eye, I'll say there is a difference. I will say vendor A is better. But when I use my statistical eye, I will go through the hypothesis testing. When hypothesis testing confirms, then I will go to DOE, next step. Why DOE? I will dive deeper to further understand, and that you will be learning tomorrow. And now see here, grand total. What is grand total? Add all the three total.
Okay.
See here, summation of the 685, 731 and 713. Now correction factor. Correction factor is this, what do you call, the total. The total value 2130 is there, This 2130 is squared, and then we divide it by, look at the formula.
Yeah, divided by count.
Count of all the number. How much is the count?
120.
No, 360. All the number.
360.
So the total is squared and divided by 360. That will give you correction factor. You remember we had N1 plus N2 plus N3. Correct? And now come to sum of squares of the data. Total sum of square. Total sum of square means the squared sum. This total should be squared, and you sum up, and then you subtract the correction factor. You have to do it manually once, then only you will understand all those things. Now come to vendor sum of square. When it comes to vendor sum of square, there are, vendor sum of square. Now each, each vendor total, we squared, am I right? We squared, see here, the formula is available. Squared sum from the B128 to D128. B128 to D128 is nothing but these three values. You square them, sum them, and then you divide by 120. Because each one had same number 120. You square them, sum them, and divide by 120. Or after squaring, immediately you can divide by 120, and then you can club them. It's same. So square each value, add all the three, divide by 120, you get this vendor sum of square. Now vendor sum of square is obtained and everything is obtained. Now you can go to the ANOVA table. See here, ANOVA table is here. Where from this we get this 8.9 vendor sum of square? It's here, right? No?
Yes.
Yeah, see here 8.9. This 8.9 is vendor sum of square. Similarly, 706 comes from here. 706 and 8.9, these are the two input required to create the ANOVA table. See here, 8.9, 706. Now this is simply the difference of 706 and 8.9. Now degree of freedom, how many vendor? 3 vendor. So what do you put? 2 only. 2 as the degree of freedom, because the formula is n minus 1. Total degree of freedom 360. 360 minus 1, 359. The difference between 359 and 2 is 357. Now mean sum of square. What is mean sum of square? This 8.9 divided by 2 will give you this. Am I right? All of you are following me?
Yes, sir.
Similarly, mean sum of square for error. This factor mean sum of square divided by error mean sum of square will give you the F value. Once the F value is obtained, the P value can be calculated. And for that, the formula is available here. See here, what is the formula? Equal to F dist and then the F value. How much is the F value? 2.28, comma, degree of freedom of the factor. Degree of freedom of the factor is how much? Come on, tell me, degree of freedom of the factor is how much?
2.
2. And degree of freedom of the error is
357.
357. Let me try this for you. The formula, let me put it here. Equal to, what should I do? F dist, right? F dist. I choose this function. What is that first I should give? F value. How much is the F value? 2.28.
2.28.
0379. What is the factor degree of freedom? 2. What is the error degree of freedom?
357.
357. Now close the bracket, enter. And your P value is generated.
Yeah.
How much is the P value? 0.10. So fail to reject the null. That means we are not going to differentiate the vendor. So this completes our understanding on the calculations behind ANOVA. I have taught you not to make you by heart the calculation, but you should know, no, there is a procedure exists, a strong procedure exists, and using which, this happens. And now the P value, you are just looking at the last step, the P value. If you use the last step correctly, that is all good enough for you to take a right decision. Now what I expect is, now I want all of you to open the Excel sheet. Data is available, and